Hello dear students, this is the next video of the chapter Reflection and Refraction of Light. This is the lengthy chapter and it takes about 20 periods to complete this chapter. So I will make 8 videos on this chapter. In this part of the video, I will explain refraction of light, cause of refraction, refraction through lenses, and atmospheric refraction. After completing chapter, I will cover some numerical questions also. So let's start refraction of light. So starting right from the refraction of light, we will see that refraction of light is the bending of light rays when it goes from one medium to another medium. Refraction is not new for you. You have already studied refraction of light in 8th standard. So it is simply the bending of light when it goes from one medium to another medium. Now it will be more clear through this diagram. Here x dash is the interface. Interface is what? It is the boundary separating two media, and this is air medium and water medium. Air medium is rarer medium relative to water. Water is the denser medium here. Now what is a rarer medium and what is a denser medium? The medium which has less optical density relative to other is called rarer medium, and denser medium more optical density, larger optical density relative to rarer medium. Now what is optical density? Actually these things are very basic things. You have already studied in class 8. That's why I am not going deep into this. So optical density is what? Optical density is simply density of the medium relative to light in terms of light, or the medium which has large number of molecule per unit volume respect to other is called optically denser. Means optically denser medium has large number of molecule per unit volume, or optically rarer medium less number of molecule per unit volume. So now this is a rarer medium and this is denser medium. Now AO is the incident ray. It falls on the interface obliquely and it will be refracted in the direction of OB. But here we are seeing that AOB dash is the actual path of light, because we already studied that light moves always in a straight line path. Light moves in a rectilinear path. So without taking its actual path, that is OB dash, it bends in the direction of OB. So this bending of light, when light goes from one medium to another medium, this bending of light is called refraction of light. Now some important points regarding refraction of light regarding this diagram, that is AON, angle AON, angle of incidence, BON dashed, BON dash, angle of diffraction denoted by angle R. AO is angle of incidence, BO refracted, sorry, AO is the incident ray and BO is the refracted ray. Now basic cause of refraction. The basic cause of refraction is the speed of light is different in different medium. Air has speed of light 3 into 10 to the power 8 meter per second. In water speed of light is this much, that is 2 into 2, 5 into 10 to the power 8 meter per second. Glass speed of light in glass is 2 into 10 to the power 8 meter per second. So here we have seen the refraction, definition of refraction and cause of refraction. Laws of refraction and Snell's law. There are two laws of refraction. One is the incident ray, the normal at the point of incident, and the refracted ray all lie in the same plane. As we have seen, there are two laws for reflection also. Similarly, there are some law for refraction also. First law says that the incident ray, the normal at the point of incident, and the refracted ray all lie in the same plane. And the second law is the ratio of sine of angle of incident to the sine of angle of refraction is a constant. Means that this is the interface separating two media. AO is the incident ray, OB is the refracted ray, ON is the normal, AON angle of incident, and BON dash angle of refraction. Now, according to second law of refraction, sin I by sin R means sine of angle of incidence to sine of angle of refraction. Sin I by sin R is a constant, also called nu. This relation is called Snell's law. Now we will see the behavior of light rays when it goes from rarer to denser medium and denser to rarer medium. The behavior of light ray when it enters from rarer to denser medium and denser to rarer medium. In first case, rarer to denser medium, I have taken rarer medium, that is air, denser medium, that is water. AO is the incident ray, AOB dash is the actual path of light, and OB is the refracted ray. ON and ON dash is the normal. In this case, light ray bends towards the normal. This is the normal, this is the actual path, and light ray bends towards the normal. Means when light ray enters from rarer to denser medium, it bends towards the normal. In another case, when light ray enters from denser to rarer medium, in this case light rays bend away from normal. See what happens. AO is the incident ray, AOB dash is the actual path, and when light enters from denser to rarer, that is from glass to air, it bends away from normal. So when light enters from rarer to denser, it bends towards the normal, and when light enters from denser to rarer, it bends away from normal. Now, refraction through a glass slab. I have taken PQRS is a glass slab, and AO is a ray which incidented on the edge, PQ on the glass slab, and refracted like that, and then emerges as it is shown. Here AOC dash is the actual path of light, and BC is the emergent light. Now we'll see some points regarding the path of light rays when it refracted through the glass slab. AO is the incident ray, angle AON, that is angle I, is angle of incident. OB is the refracted ray, and angle BON dashed, this is N, this is O, and this is N dashed. So BON dash is angle of refraction. Again, for the edge SR, this angle, that is OBN1, this is N1 and this is N1 dash, N1 dash. For this edge SR, this angle, that is OBN1 will be angle of incidence, and we are seeing that PQ and SR are parallel and OB is a transversal line. So these two angles will be treated as alternate interior angle. I am repeating it. Listen carefully. PQ and SR are parallel and angles N dash OB, that is this angle, N1 BO, that is this angle, will be equal. So this angle is R, this will also be R, and BC will be the emergent ray, and angle CBN1 dash will be denoted as angle E, and this is called angle of emergence. And here we are seeing that the actual path of light and the emergent light both are parallel to each other. So there is a distance between them. Both the rays are separated by a certain distance. So this distance is called parallel shift or lateral shift or lateral displacement. Parallel shift, lateral shift or lateral displacement. This distance between actual path of light and emergent light. Now in exams there may be question that trace the path of light rays when it refracted through the glass slab. So the path will be like that. Some important points, some important terms regarding the refraction of light through glass slab I have written here. AO is the incident ray, OB is the ON is the normal, OB is the refracted ray, AON, that is angle I, angle of incidence, BON dash, that is angle R, angle of refraction, and OBN, OBN1, that is OBN1, this angle, and BON dash, that is BON dash, means this angle and this angle will be equal. Both angle is denoted by R because PQ and RS are parallel. CBN dash, that is angle of emergence, CBN1 dash, BC is the emergent ray, OC dash is actual path of light ray, So D is called lateral shift or lateral displacement. So this was the explanation of refraction through glass slab. The important part is that light ray do not bend when it enters from one medium to another medium normally. Means with an angle 90 degree with the interface. So when it will make 90 degree with the interface, that is when light enters normally from one medium to another medium, it will not bend. It will bend only when it enters obliquely from one medium to another medium. Here I have taken two medium, that is air and water, and light entering from air to water with an angle 90 degree with the interface. So we are seeing that light rays going straight in a straight direction, that is in rectilinear path. So light ray entering from air to water normally, means with an angle 90 degree. Light ray entering from one medium to another medium obliquely, that is with an angle other than 90 degree, then only light will bend. So light ray entering from air to water obliquely in case of light ray is bending. So this is the most important part. Now in next part I will explain lenses and refraction through lenses. So stay tuned with me for further videos.